Hi guys, Miss King here. Just going to do a lesson on counting combinations. So the first thing to understand is what a combination is, the number of ways in which a subset of objects can be selected from a given set of objects where order is not important. So the first example, if I use the letters A, B, C, D, I can find all the possible combinations using two of the letters. So I'm going to start off by writing that out for us. So we're looking for the possible combinations just using two letters. So I can start off with AB, AC, AD, BC, BD, and the last one CD. Okay, if I'm to look at AB, I could also have the combination BA, but it's the exact same and the order doesn't matter, so I don't need to count that. So I can draw a line straight through that. So our total number of possibilities are 6 possibilities. Okay, now if we were dealing with bigger numbers, we wouldn't have to list them out every time, so we are going to come up with a way of doing that a little bit quicker. So give me a second. The factorial formula for combinations is what we've seen already with binomial theorem. So the number of combinations or subsets of n distinct things taken r at a time where r is less than or equal to n can be calculated as the following. So it's n choose r, so the combination capital C, it helps if you associate it with choose. So n choose r is equal to n factorial all over r factorial on n take r factorial. Okay, so we can look at a couple of different examples in this. But just quickly, I'm going to just describe what the n stands for. So the n stands for the number in the collection. And the r stands for the number taken from the collection. Okay, so on the next page, there's a couple of examples. So evaluate each problem. I'm going to start with A. So it's 5 choose 3. So 5 choose 3 is going to give me 5 factorial all over 3 factorial, and then I do 5 take 3, which is 2 factorial. Okay, so that's equal to 5 times 4 times 3 times 2 times 1 all over 3 times 2 times 1 times 2 times 1. I don't want to have to write out that 2 times 1 and the 2 times 1 on the top and bottom because they're going to cancel eventually. So if I'm choosing 3, then I'm going to have 3 numbers on the top from my factorial 5. So I'll just explain to you what I'm talking about. So if I've got a 3 on the bottom here, then I'm going to have 5, 4 and 3, and that's going to be the equivalent to 3, 2 and the 1 on the bottom. So that's a quick way to do it. So I end up with 5 times 4 times 3, all divided by 3 times 2 times 1, which is equal to 60. Sorry, I need to go back to my pen. So the answer is 60. It's same for this one. If I have 6, choose 6, I'm going to be doing 6 factorial all over 6 factorial, and then 6 take 6 is 0 factorial. We know from the last day that 6 factorial over 6 factorial times 0 factorial, the 0 factorial is equal to 1. So I end up with 1 over 1, which is just equal to 1. So for this one, it's a worded question, so you need to figure out what your n is and what your 3 is. So I have to find the number of different subsets of a size 3 in the set MathRocks. So MathRocks is 9 elements, so I'm going to choose from 9, and I want to choose 3, so it's going to be 9 choose 3. So that's going to be equal to 9 times 8 times 7 all over 3 times 2 times 1. Okay, and when I work that one out, I get 84. Another worded question, if I was to look at how many different ways there are to choose 6 out of 10 books and order does not matter. Again, I'm using combinations because order doesn't matter, so I'm going to look at 10 choose 6, which is going to be equal to 10 times 9 times 8 times 7. Sorry guys, just jumping around the page. 7 times 6 times 5 all over 6 times 5 times 4 times 3 times 2 times 1. And when I work all that out, I end up with 210 books. Okay, so pretty easy. You're just pulling the numbers from context. A common form of poker involves hands or sets of 5 cards each, dealt from a deck consisting of 52 different cards. How many different 5-card hands are possible? Okay, so repetitions are not allowed and order is not important. So therefore you cannot have a king of clubs twice, but it doesn't matter if the king of clubs is your second or your third or your fourth card in your hand, order doesn't matter. Okay, so give that one a go on your own. Another thing that you need to also take into consideration is that rather than writing out the formula for large values of R, you should use it symmetrical to change to a smaller number. Okay, so if I want to choose 18 players from a squad of 24 for a football game, I can say that essentially I'm trying to choose 24, choose 18, but that's actually the same as 24, and the difference between 18 and 24 is 6, so it's the same as 24, choose 6. So it just makes it a little bit shorter when I'm writing it out. So 24 times 23 times 20. Sorry, my hand keeps getting in the way. 22 times 21 times 20 times 19 all over. So notice I've only got 6 terms. 6 times 5 times 4 times 3 times 2 times 1, because my 18 factorial on the top and the bottom will cancel out. And I end up with 134,596 ways of choosing 18 people for the team. Okay. If you want to use your CAS calculator, this is what you're going to do. So you go into choose PRB, and it'll be number 3 on the CAS. If you're on your green calculator, it'll be number 2. So you're looking for NCR, so N choose R. So 10 choose 6. You put in your 10 first of all, then choose your NCR, and then you work out your answer to be 210. Okay, that's it from me. Thanks.